All right, guys. Hope everybody's doing well. So what I'm going to do is I'm just going to kind of run through the practice test that I gave you. You guys can check your answers as you work your way through it. And as always, you can come see me if you have any other questions. I'm going to put the times for each question down in the description. So if you wanted to say skip the first couple questions, but maybe we'll go to right to number 5. You could do that by just clicking on the times. Um, yeah, so let's get started. The first one you guys have to do is graph 3 to the x plus 2 minus 2. All right, so this is a exponential function. All right, and the reason that I know that is because it's 3 to raised to something. Okay, and this is a base of 3. Okay, and that tells me that this is going to be a growth function. All right, so I know that as it should kind of look something similar to that, right? That's our parent function, and I know because it's a base is bigger than 1, it's going to look similar to that. All right, I also know that it's going to be moving left 2 and then down 2. Okay, so what I'm going to do is I'm just going to draw like the parent function and then transform it from there. All right, so the parent function looks something like that. Okay, so you guys want to make sure that it's going through 0, 1, right? That's the y-intercept, and then you're gonna do your graph from there. Okay, so I know that I should be moving 0, 1. I know that needs to go left 2 and then down 2. So that's going to put me at -2, -1. Okay. Now, because of I normally have a horizontal asymptote at y equals 0, but because the graph is moving down 2, that's where the asymptote should go. So you should have an asymptote at y equals -2. Okay, and then from there, all we're doing is we're just drawing the graph, so it should look like a growth. All right, so that's pretty much what 3 to the x plus 2 minus 2 looks like. All right, so I'm just going to get rid of the original. Okay. So from there, I'm going to figure out what all the properties are. So I know that the domain is all real numbers. That's the same for any exponential. The range is going to go from -2 to infinity, so from the asymptote and above. The y-intercept, so I'll probably ask you what the y-intercept is, and then for the x-intercept, I'll ask you that for a log function. So the y-intercept is when you plug in 0, so it's going to be 3 to the 0 plus 2 minus 2, so that's going to be 3 squared minus 2, which is 7. Okay, so I should actually probably fix my graph a little bit to make sure that it goes through 0, 7. Okay, so I'm going to go through that point, and then go up like that. So that's probably a better representation of what the graph looks like. All right, so my y-intercept, right, we figured out was 0, 7, and then my horizontal asymptote was at y equals -2. Okay, so if you guys can figure out all that information, you should be fine for what what you're going to be asked to do on on Tuesday. So that's how you do the first one. All right. So the second one, negative e to the x plus 4. Okay. So it's another exponential. All right. So it's a base is e. Okay. And I know that's going to be a growth. All right. The negative on the outside is a reflection over the x, and it's going to move up 4. Okay. So I'm just going to draw the regular graph first and then do the reflection next. So you have the regular e to the x. Okay, that looks like that. Again, going through 0, 0, 1. But now when I flip it over, right, I'm going to flip it over the x-axis. Okay. Now it should look something like that. All right, so this first one that I drew was e to the x. The second one that I drew is negative e to the x. Okay, so you should be going through 0, negative 1 now instead of 0, 1. Okay, and then what we're going to do from there is we're just going to move the graph up 4. Okay, so 0, negative 1 is going to move to 3, 0. All right, and then you also know that your asymptote, since the whole thing, even though I did the reflection, it's still at y equals 0. So if I move the graph up 4, it should go through y equals 4. Okay, and then all I'm going to do now is just finish what the regular graph looks like. All right, so what I have there in the blue is negative e to the x plus 4. Okay, so I'm just going to get rid of the other ones for now. Okay, so the domain again for this one is just going to be all real numbers. The range now, so because we did the reflection, it's going to start from negative infinity and then stop at positive 4. The y-intercept, because we didn't move it really left or right at all, we just moved it up or down, is going to be 0, 3. And then the horizontal asymptote is going to be y equals 4. All right, so again, if you can figure out that information, you guys should be pretty ready to go to graph really any exponential on the test. Okay, so moving on to the third one, that's negative log base 2 of x minus 4. So f of x equals negative log base 2 of x plus 4 minus 4. Sorry about that. Okay, so I know that this is a log graph. All right, so this is a logarithmic function. Okay, so my base here is 2. Okay, so I know that that also means that this should be a growth function. Right, now if your base is less than 1, right, say if it's like a fraction, then it's a decay. It's going to have a different shape to it. So any log graph looks very similar to this. Okay, so it's going to go through 0, 1, 0, and then have a vertical asymptote at 0 at x equals 0. So what we're going to do is just kind of change what that graph looks like. So this one has a reflection over the x, and then it's moving to the right 4 units. Okay, so I'm going to do the reflection first. So I know that up here is what the regular log graph looks like, right? And then I'm just going to take that, I'm going to flip it over the x-axis now. Okay, so it's going to look something like that. Okay, So still going through 1, 0, right? But the direction is a little bit different. Okay, so then what I'm going to do is I'm going to take that point, 1, 0, and I'm going to move it to the right 4 units. Okay, so now it should go through 5, 0. Okay, now I originally had my asymptote at x equals 0, but that also is going to get shifted 4 units to the right. Okay, so it should be going through x equals 4 now. So I'm going to draw that. All right, and then all I need to do is just draw that same shape, making sure that I go through 5, 0. Okay, so that's what your log graph is going to look like. So I'm going to get rid of this stuff here. All right, so for the domain now, it's going to go from the asymptote and then to the right. So it's going to be from 4 to infinity. The range is all real numbers. Your x-intercept is 5, 0, right? So because it's a log graph, I'm going to ask you what the x-intercept is, not the y-intercept. And then the vertical asymptote is x equals 4, okay? So again, you guys want to make sure that when you're writing the asymptote, you're writing it as an equation, okay? So x equals 4 is the proper way to do that. You don't want to just write vertical asymptote at 4, okay? That's not very specific. So if you write it as an equation, that's a much better, more specific, location of where your asymptote's at. Okay, and then moving on to the last graph, it's ln of 2 minus x plus 1. So this is ln of 2 minus x plus 1. Okay, so what I want to do is I want to put that in a standard form first. So I'm going to switch the 2 and the x. So I'll make that ln of negative x plus 2. And then what I'm going to do is I'm going to factor away the negative sign so I know exactly what my shift is. So if I do that, I'm going to take out the negative. That's going to make it x minus 2 on the inside. All right, so again, this is another log graph, another growth, because the base is e now. All right, so because of the negative there on the inside, I have a reflection over the y-axis. I'm going to be moving it right 2 and then up 1. Okay, so when I do this graph, right, I want to do the reflection first and then the shifts up or down, left and right. Okay, so I'm going to start with just ln of x. Okay, so that's ln of x there. It's going through 1, 0 like we've been doing. Right, now that's going to flip over the y-axis. Okay, again, because of that negative that's on the inside. Okay, so now that's going to go, it's going to look something like that. All right, so that's now ln of negative x, which is what we have. Okay, so that's what you're going to move now to the right and then move it up 1. Okay, so I'm going to take negative 1, 0, and I'm going to move it right 2 and then up 1. So it should go right through right there. Okay. So let me get rid of these other graphs. Okay. Now, because I moved the graph right 2, my asymptote, which was originally at 0, should now be at x equals 2. Okay, and then I'm just going to draw the same shape as I have already, making sure that it goes through 1, 1. All right, so that's your function there. So I'm going to get rid of that. Okay, so now I want to write the domain. So the domain now is going from negative infinity to 2, okay, because that's where my asymptote's at. My range is all real numbers. I have a vertical asymptote at x equals 2, okay. Now my x-intercept is going to be a little bit different, okay, because we move the graph around. I don't know exactly what, what this point is, okay, but I can figure that out just setting it up. Okay, so my x-intercept, right, I'm going to take ln of 2 minus x plus 1, and I'm going to set it equal to 0. Okay, so if you're figuring out an x-intercept, you set the whole equation equal to 0, because the y term will be 0. Okay, so I'm going to subtract the 1 over, make it ln of 2 minus x equals negative 1. Okay, now what I want to do is I'm going to write it as an exponential form. Okay, so I know that because I'm using ln, it has to be base e. Okay, so base e. So just write it now as an exponential. So e to the negative first is going to give me 2 minus x. So e to the negative first gives me 2 minus x. Okay, now all I want to do is just want to solve for x. So I'm going to subtract the 2 over, and then I'm going to divide the negative 1 into each thing. So that's going to make it negative e to the negative first plus 2. Okay, so your x-intercept now is negative e to the negative first plus 2, comma, 0. Okay, so if you guys have a question like that on the test, I would leave it like that. Okay, leave it in that form. Okay, you don't need to use your calculator. You don't need to give me a decimal answer. Just leave it exactly like that. Okay, because that's the exact x-intercept. All right, so again, if you can remember the basic shapes of those graphs and then just know your transformations, you should be ready, should be pretty good to go. Okay, moving on to the next one. Number 5 says find the domain of the following logarithmic functions. Okay, so for any domain for a log graph, okay, whatever it happens to be, okay, the domain has to be greater than 0. Okay, so what that means is that I can't take the log of something that's negative, or I can't take the log of something that's 0. Okay, so I want to make sure what I'm taking the log of, what numbers are going to make that what's on the inside, or what I'm taking the log of. I have to make sure that that's positive. All right, so for the first one, I want to make sure that this x squared minus 3x plus 2 comes out to be positive. So that's x squared minus 3x plus 2. I want that to make sure that it's positive. All right, now because this is a quadratic, okay, so it's a quadratic because of the exponent, and it's an inequality, I'm going to need to set up a number line. Okay, you don't always have to set up a number line, but for ones that are like a quadratic inequality, you do. Okay, so the first thing you want to do is you want to factor it. Make that x minus 2, x minus 1. Okay, so I know that this equation is going to equal 0 at x equals 2 and x equals 1. Okay, so those are the two numbers that I'm going to test around. So I'm going to test around 1 and 2. So I'm going to pick numbers that are a little bit less than 1, so like 0. Something in the middle, so like 1.5. And then something bigger than 2, say like 3. Okay, now you can plug it into either the original, x squared minus 3x plus 2, or you can plug it into the factored one. It's really your preference. Okay, and again, you're more concerned with whether it's positive or negative than the exact number. Okay, so if you plug in 0, I have 0 squared minus 0 plus 2, that's going to be positive. Okay, if I plug in 1.5, I'm going to plug that into the factor form because that might be a little bit easier. So 1.5 minus 2 times 1.5 minus 1. Okay, so 1.5 minus 2 is going to be a negative number. And then 1.5 minus 1 is going to be a positive number. Okay? So a negative times a positive, obviously, is a negative. And then if I plug in 3, that's going to give me 3 minus 2 times 3 minus 1. So 3 minus 2 is positive, and 3 minus 1 is also positive. So positive times a positive is positive. Okay? So anything less than 1 and anything greater than 2 are going to give me positive answers into x squared minus 3x plus 2, right? And then those numbers I can figure out, what the log base 2 of. Okay, so your final answer for your domain is going to be from negative infinity to 1 union with 2 to infinity. All right, so that's how you do one if you have a quadratic inside of your log function. Okay, so for number 6, same thing. Got to make sure that this quadratic comes out to be positive. So I know I can take out a 3x. That leaves me with x minus 2. All right, so I know that I would have zeros at 0 and 2. Okay, so what I'm going to do is I'm going to test around, say, negative 1. I'm going to test around 1 and then 3. All right. Okay, so if you plug in negative 1, right? 3 times negative 1 is negative, okay? And then negative 1 minus 2 is also negative. So negative times a negative is positive. If I plug in 1, 3 times 1 is positive, 1 minus 2 is negative. Positive times a negative is negative. And then if I plug in 3, 3 times 3 is positive, 3 minus 2 is also positive. Okay, so numbers less than 0 and greater than 2 are the ones that are going to work here. So my domain now is going to be from negative infinity to 0 union with 2 to infinity. Okay, and then number 7. So number 7 is a little bit different. Okay, so you kind of have to set up two things. So the first thing that you want to worry about is, because this is an ln function or a log function, okay, you got to make sure what's inside the log is positive. Okay, so that's the first part. So I'm going to make sure that the square root of x minus 10 is greater than 0. Okay. And then the second thing I have to make sure is, because this whole thing is a fraction, okay? So I have to make sure that what's inside the denominator doesn't come out to be 0, okay? So I'm going to do the first part, the ln part first. So I'm going to add the 10 over, right? And then I'm going to make sure that I square both sides. So that's going to make sure that x has to be greater than 100, okay? So any number less than 100, right, it's not gonna work, okay? Because it's going to give me a negative number inside of the square root of x minus 10, okay? And then the second part is I have to figure out what x can't equal, okay? So again, I'm going to write this as an exponential form. So I know that because it's ln, it's base e. So e to the 0 can't equal the square root of x minus 10. So e to the 0 can't equal the square root of x minus 10. So I know e to the 0 is 1. All right, I'm going to add the 10 over, which will make me 11. So the square root of x can't be 11. And then if you square both sides, you know that x can't equal 121. Okay. Now you're going to make sure you want to look at these two together now, okay? Because these are both going to be parts of your domain. All right. Now I know that 121 is obviously bigger than 100, okay, so I have to make sure that I include that part when I write the domain. Now, if 121 wasn't in that inequality up here, okay, then you don't need to include it, right? But in this case, since 121 is bigger than 100, I do need to, okay? So you want to make sure that you start at 100 and then you're going to skip over 121. So your domain is going to start at 100, go to 121, skip over 121, and then go towards infinity. All right, so again, we did that because, again, you have to make sure that what you're taking the log of, right, that's positive, okay? And then you also want to make sure that your denominator doesn't come out to be 0 because this whole thing is a fraction, okay? So that's why that one's a two-parter. Okay, moving on to number 8 and 9. These are finding the inverse, and then you want to check your answer by showing that f of your inverse is going to equal x. Okay, so I have f of x here, right? And if I want to find the inverse, the first thing that I need to do is I need to switch x and y. So I have x equals 2 minus y divided by 3 plus y. All right, and again, your goal is to solve for the y term, okay? So because of that, I want to make sure, I want to get rid of that fraction because I need to get rid of that denominator there. So I'm going to multiply by 3 plus y on both sides. All right, so by multiplying by 3 plus y on the right side, this and this are going to cancel, okay? And then I'm just left with 2 minus y on the right. And then on the left, I'm going to distribute. That's going to give me 3x plus xy. Okay, so now everything is linear, which is what I want. Okay, so now what I want to make sure I have all the y terms on the left side, all the things that don't have a y term on the right side. Okay, so I'm going to add the y over. So that's now 3x plus xy plus y equals 2. And then I'm going to subtract the 3x over because that doesn't have a y term. So now I have xy plus y equals 2 minus 3x. Right? And then I see on the left side I have a y term in common. So I'm going to factor that out, leave me with x plus 1 equals 2 minus 3x. Okay? And then again, because you're trying to solve for y, you're going to divide x plus 1 over. So y is equal to 2 minus 3x divided by x plus 1. So your inverse now is 2 minus 3x divided by x plus 1. Okay? So what I want to do now is I want to make sure I got the right answer. Okay, so I need to check it. So when you check it, you want to make sure that when you plug in the inverse, everything cancels out and you're just left with x. Okay, so anywhere you see an x term, you're going to plug in what you just found to be the inverse. Okay, so I have 2 minus 3x over x plus 1, and then 2 minus 3x over x plus 1. Okay, so what I can do from there is I want to get rid of those denominators of x plus 1, x plus 1. So if I multiply on the top and the bottom by x plus 1, that's going to allow me to do that. All right, so again, you guys want to make sure that you're taking that x plus 1 and it's going to both terms in the top, both terms in the bottom. So multiplies to the 2 there. So 2 times x plus 1 gives me 2x plus 2. And then x plus 1 times what I have there in the parentheses, the x plus 1s are going to cancel. So you're left with minus 2 plus 3x. All right, you want to make sure that you distribute your negative sign there. All right, so negative 2 plus 3x. Okay, and then there on the bottom, again, I'm going to take the x plus 1, multiply it to 3. So that's going to give me 3x plus 3. And then, again, multiply it to what I have there in the parentheses. Again, the x plus 1s should cancel out. So you're going to be left with plus 2 minus 3x. Okay? So now that you've gotten rid of those fractions, all you're going to do now is you're just simplifying. So my 2's are going to cancel, right? And then 2x plus 3x is 5x. And then the 3x and the negative 3x are going to cancel. And then 3 plus 2 is 5. So 5x divided by 5 is x. And that's what you wanted. Okay? Now, again, if you don't get just one x, then you need to maybe go back and check your work for your inverse, because maybe you made a mistake along the way. Okay, and then moving on to number 9, same thing. Again, you're going to switch x and y, so x is now going to be equal to negative 4 fifth root of y minus 10 minus 8. Okay, so anything that's on the outside of the fifth root, I need to move that over first. Okay, so that's going to include this negative 4, and that's going to include the minus 8. Okay, so I'm going to move the minus 8 over first, make that x plus 8 equals negative 4 fifth root of y minus 10, and then I'm going to divide the negative 4 over. So now I have x plus 8 divided by negative 4 equals the fifth root of y minus 10. Okay, so now to get rid of that fifth root, right, I need to raise both sides to the fifth power. All right, now you guys don't need to multiply the left side out. You can leave it as it is. So x plus 8 over negative 4 to the 8th power gives me, now when I take the fifth root and I raise it to the 5th power, they're going to cancel. So now I'm left with y minus 10. And then all you need to do from there, that should be the 5th power, not the 8th power. All you need to do there is you just need to add the 10 over. So you've got x plus 8 divided by negative 4 to the 5th power plus 10. So my inverse now is x plus 8 divided by negative 4 to the 5th plus 10. Okay, so what I'm going to do now is I'm just going to check it, make sure that I got the right answer. Okay, so I got negative 4 fifth root of x minus 10 minus 8 there. Okay, so all right, so I got x plus 8 divided by negative 4 to the 5th plus 10. Okay, so the first thing that I can get rid of the plus 10 and the minus 10 right inside the radical there. So now you got negative 4 fifth root of x plus 8 divided by negative 4 to the 5th minus 8. Okay, so the next thing that I can get rid of is if I'm taking the fifth root of something raised to the 5th power, they're going to cancel. So now I got negative 4 times x plus 8 over negative 4 minus 8. Okay, the next thing I can get rid of is these negative 4's, right, when you multiply. So now I got x plus 8 minus 8, and that obviously is going to give me 1x. All right, so that tells me that I got the right function. Okay, moving on to number 10 and 11. So they're asking you to find f of g of x and g of f of x, as well as find the domain for each. Okay, so f of g of x, and then g of f of x. All right, so the first one that I'm going to do is going to be f of g of x. All right, so the first thing that you guys have to do is you have to find the domain of what you're plugging in on the inside. Okay, so I'm going to plug in g of x first. I need to figure out what the domain is. So find domain of g of x. Okay, so the domain of g of x, right, this is a quadratic, right? I can plug whatever I'd like into a quadratic and I'm going to get an answer back. Okay, so the domain of a quadratic is just all real numbers. Okay, so I can move on. I can move on from there. Okay. Okay, so now what I want to do is I'm going to plug in. Excuse me. I'm going to plug in g of x anywhere I see an x term in f of x. So it would be 3 times 2x squared minus 1. All right, and then this is going to be now 6x squared minus 3. Okay, so that this is now f of g of x. All right, now you're probably not going to have one that looks like this on the test, because this is now you have a quadratic underneath the square root. I'm going to work through it, but you're probably not going to see one on the test on Tuesday that looks like this. Because to figure out the domain of this, right, I have to make sure what's inside my square root is greater than or equal to 0. Okay, so this is now a quadratic inequality, and we haven't really talked too much about that. When we're doing these. So I'm going to run through it, but again, probably not going to see one that looks like this. So 6x squared minus 3. Okay, so if I could take out, say, a 3, that's going to leave me with 2x squared minus 1 greater than or equal to 0. All right, so that's going to leave me with So x would come out to be equaling plus or minus the square root of 1 over 2, which is the same thing as the square root of 2 over 2. All right, so I'm going to just test around that. All right, so say I can plug in, say, like -3, plug in 0, try 3. Okay, so again, I want to make sure that it's going to come out to be positive. So if I plug in -3, that's going to be positive. If I plug in 0, negative, plug in 3, also positive. Okay, so your domain for this one is going to be from -infinity to -√2 over 2, and then union with √2 over 2 to infinity. All right, so like I said, guys, you're probably not going to have one that's going to be that tricky. All right, so let's move on to the next one. All right, so that we just did f of g of x. Now we're going to try and do g of f of x. All right, so the first thing I need to do is I need to figure out the domain of f of x. Okay, so find domain of f of x. All right, so again, because this is a square root, I have to make sure what's inside is greater than or equal to 0. All right, so that tells me that x has to be greater than or equal to 0. Okay, so I need to remember that when I write my final answer. All right, so now when I do g of f of x, it's going to be 2 times square root of 3x squared minus 1. Okay, now when you square the square root of 3x, that just becomes 3x. So your final answer is going to be 6x minus 1. Okay, and then you also, when you write your final answer, you have to include your domain, right? So 6x minus 1 is just linear, so I can plug whatever I want into that. But from what I just found for the domain of f of x, I have to make sure that it's greater than 0. Okay, so my final answer, so g of f of x, is going to be 6x minus 1. X has to be greater than or equal to 0. Okay, so again, if you plug in anything less than 0, you're not going to be able to get an answer for f of x, and then you're not going to be able to get an answer for then g of f of x. So if the inside doesn't work, the whole thing's not going to work. So that there would be your final answer. Okay, so moving on to number 11 now. All right, so we got f of g of x. All right, so the domain, I need to find the domain of g of x first. So g of x equals 3 over x. So the domain of that, right, x can't be 0. Can't plug 0 into the denominator. All right, so that's going to be the first part. So now when I do f of g of x, right, now I'm going to have the square root of 3 over x minus 3. Right, again, anywhere you see an x term, you replace with g of x. Okay, now to find the domain of that, I have to make sure that 3 over x minus 3 comes out to be greater than or equal to 0. Okay, so I could add the 3 over. I can multiply the x over. And then I can divide the 3 to the other side. So 1 is less than or equal to x, or x is less than or equal to 1. Okay, so when I write my answer now, I need to make sure that I include both of those together. Okay, so my answer for f of g of x is going to be the square root of 3 over x minus 3, and then the domain is going to be from -infinity to 0, union with 0 to 1, close brackets. All right, so again, putting both x can't be 0 and x is less than or equal to 1 gives me this domain that I have highlighted there. Okay, and then the last part, right, we're going to figure out g of f of x now. Okay, so need to figure out the domain of f of x first. All right, so f of x equals the square root of x minus 3. All right, so because it's a square root, x minus 3 has to be greater than or equal to 0, right? What's inside has to be positive. So x has to be greater than or equal to 3. All right, and then now when I do g of f of x, right, anywhere I see an x term in g of x, I have to replace it with the square root of x minus 3. So I'm going to have 3 over the square root of x minus 3. Okay, so the domain of that, right, because it's a fraction, I have to make sure that what's inside comes out to be positive or equal to 0. So that's x is greater than or equal to 3. Okay, and I have to make sure that the whole denominator doesn't equal 0. Okay, so that would be, if I square both sides, x minus 3 can't be 0, x can't be 3. Okay, so if you put both of these together now, x has to be greater than or equal to 3, x can't equal 3. That concludes that x has to be greater than 3. Okay, because you can't equal 3 because it's not going to work. All right, so my final answer is going to be 3 over the square root of x minus 3, and then x has to be greater than 3. Right, or you can also do the domain would be 3 to infinity. Either way is okay with me. All right, so that's your composition functions. All right, and then the last section is just evaluating the logs. All right, so you guys have to remember you want to write these right into exponential form. Okay, and you also want to get the bases the same. Okay, so if you can do those two parts, you should be, really have no problems with these. Okay, so the first one is log of 1 over 5 of 625. So 1 over 5 to some power is going to give me 625. All right, so both of these are going to have, I think, base 5 in common. So base 5. All right, so 1 over 5 is the same thing as 5 to the negative first. All right, and 625 is the same thing as 5 to the fourth. So I have 5 to the negative x equals 5 to the fourth. Right? Now that the bases are the same, that means that their exponents have to be the same. So negative x equals 4, so x has to be negative 4. So negative 4 would be my answer. Okay, so this one is now log of the cube root of 10 to the 5th. Now remember, if you don't have a base written, so no base written, all right, that means that it's base 10. Right, that's the common base. It's just the way that we write it in mathematics, that you just don't write the base if you're talking about base 10. So this is going to be now 10 to the some power is going to give me the cube root of 10 to the 5th. Okay. So what I want to do is I want to rewrite the right side so that it has an exponent. So if I take the cube root of 10 to the 5th, that's the same thing as saying this is 10 to the 5/3. Okay, that's the same operation. Okay, so the root goes in your denominator of your exponent. The exponent goes in the numerator. Okay, so 10 to the some power gives me 10 to the 5/3. So x must be 5/3. All right, and then 14 ln of 1 over e to the negative 2/3. Right, so if it's ln of x, it's base e. All right, we talked about that already. So this is e to some power gives me 1 over e to the negative 2/3. Now 1 over e to the negative 2/3 is actually e to the 2/3. Right, so if you use your properties of exponents, if it's negative, right, you need to move it. So that means that x must be 2/3. All right. So now the 15, 2 times log base 9 of 27. Now you can do this really two ways. First way that you can do it is you can actually move the 2 and make it raise it to 27. So this can now be log base 9 of 27 squared. Okay, so this will now turn into 9 to the some power, gives me 27 squared. Right, now both of these I know are going to have a base 3 in common. So I know that 9 is the same thing as 3 squared. And I know that 27 is the same thing as 3 to the third. So now I have 3 to the 2x gives me 3 to the sixth. So 2x equals 6. X must be 3. All right, that's one way to do it. Now the other way is just to actually figure out what's log base 9 of 27 and then multiply your answer by 2. So you have 9 to the x gives you 27. Again, 9 is 3 squared, so you have 3 to the 2x. 27 is 3 to the third. So now you got 2x equals 3. X equals 3 halves. And then you're just going to take your answer and multiply it by 3 halves. So 2 times 3 over 2 is just 3. Okay, so obviously you can see we got the same answer. Okay, now you don't need to do it both ways. You can do it one or the other. Whatever's easier for you guys. The first way is using a property of logs, which we're going to get into probably within the next week, and then the second way is just simplifying. So whatever is more convenient for you guys. Okay, so the same thing here. I can take this 3 and I can move it up top. So make this ln e squared to the third. Okay, so that's now going to be ln of e to the sixth. Okay, so e to what power gives me e to the sixth? So x would be 6. All right, and then the last one, 2 times log of 100 divided by 3 times ln of e to the 5. Okay, so this is now going to become log of 100 squared divided by ln of e to the 15th. All right, now let's see. So log of 100 squared, right? That's 10 to some power, gives me 100 squared. Okay, so I know 100 is 10 squared. So that's 10 to some power gives me 10 to the fourth. All right, so the top part must be 4. Okay, so this is going to come out to be 4. And then on the bottom, right, ln of e to the 15th. Okay, so e to some power gives me e to the 15th. X must be 15, so the bottom is 15. So your answer is 4 over 15. All right, guys, so that's pretty much the practice test. So if you look over that, look over the notes, you guys should be pretty good to go. As always, try and come see me for extra help if you need it, and I'll see you next week. Thanks.